Hello everybody, and welcome to Lecture 9. In this lecture we'll be going over indexing arrays. Okay, so we're going to import NumPy as NP. Alt-Enter to get a new cell and run it. Let's go ahead and create a sample array. So in this case I'll just call it ARR, and I'm going to set it equal to np.arrange. And let's go from 0 to 11. So in this case, and then let's go ahead and show it. Think about what you expect to see here before you click Alt-Enter. And let's go ahead and see it. Okay, so hopefully you figured out that the index starts at 0. So in this case, calling it all the way to 11 means I would get 10. Here we go, 11 points, 0 through 10. And if I want to get a value at an index, I can say call the value at 8, index 8, and that should be equal to 8, which makes sense because if I go 0, 1, 2, 3, 4, 5, 6, 7, 8, I'll end up at 8. Great. So what if I want to get the values in a particular range? I can also do that by inputting a range from 1 all the way to 5. And remember, this should go to 1 before 5, so it should output 1, 2, 3, and 4. Let's go ahead and see if that's true. And it did, so it outputted 1, 2, 3, and 4 in your array. Perfect. And let's go ahead and get the values in a range again. So how about 0 through 5, and that gets us 0, 1, 2, 3, 4. Okay, so that's how you can get values in a range. You can also set a value with an index range. So I can say from the range 0 to 5, I can set all those values equal to 100. So before you click enter, think about what's going to happen. I'm telling Python to say, hey, all the values from 0 to 5, go ahead and set them equal to 100. But remember, you start at 0, so it should be 0, 1, 2, 3, and 4. Those 5 numbers should be equal to 100. And then it'll go 5, 6, 7, 8, 9, 10. So we should expect 5 instances of the number 100, and then 5, 6, 7, 8, 9, 10. Let's go ahead and see what our array looks like now. And we got just that. So here we have the 5 100s, so 0, 1, 2, 3, and 4 were turned into 100, and then we have 5, 6, 7, 8, 9, 10. Alright, perfect. Let's go ahead and just reset this array. So I'm going to say np.arrange 0, 11 again. Let's see what it looks like. So I have my 0 through 10, the 11 points. And now we can do slices of an array. So I can set an object to be equal to slice underscore of ARR and set that equal to the range from 0 to 6. So in this case, I would expect slice of R to, or array, depending how you want to say it, to be equal to 0, 1, 2, 3, 4, 5. So those are 6 values there. And then let's just type it out so we can see what that looks like. Okay, and there we have it. Here are the 6 values, 0, 1, 2, 3, 4, 5, and now we created a slice of the array in that same fashion. We can go ahead and change the slice. So I can say slice of R or array. I could say, using a colon, say all the elements in that array are now equal to 99. And let's go ahead and check if that is what happened. And that's the case. So using that colon, you can select all the elements in your array. So now note that the changes also occur in our original array. So what do I mean by that? I'm going to show you the original array. Now you might be thinking, whoa, that's weird. I was only changing values in slice of array, not in my array itself. Well, in NumPy, this data isn't copied, it's just a view of the original array. So this avoids memory problems. That way you don't have several copies of your array floating around. You only have one copy of your array, and if you grab slices of it and change stuff, change the elements, it's going to affect your original array. So that's something to really keep in mind when you're messing around with arrays. If you don't want that to happen and you want to get a copy, you got to be explicit. So if I say ARR copy equal to ARR, that will still affect your original array. It's not going to actually make a copy. What I have to do is explicitly say copy. So dot copy, parentheses, no extra arguments. And then I can look at this array, and now I have a copy of it. Alright, great. So let's learn about indexing in a 2D array. So let me make an object called ARR underscore 2D and use np.array. And then as we've done in the past, I'm going to put in several lists, so I can say something like, let's see, let's go ahead and go in powers of, or counts of 5, so like 5, 10, 15, that'll be one list. Then 20, 25, 30, that's another list. And then my next one I can say 35, 40, 45. Alright, and then let's go ahead and show that by typing it out. Alright, excellent. So now I have a 3x3 2D array. Awesome. So how can I index this? I'll type out my r underscore 2D, and if I want to see a row, I can type in the index of that row. So think about for a second before you click Alt-Enter what this should be. And remember, in Python and NumPy, your index starts at 0. So what do we expect to see here? We see the row of 20, 25, and 30. So that makes sense because your index starts at 0, and what I mean by that is if I called 0, I would see the first row here, 5, 10, 15. So here's your 0 index row, here's your 1 index row, and then here's your 2 index row. Alright, great. What if you want a individual element value? Well, you can do that as well. You can just say the row you want, and then also ask for the column you want. Okay, so think about it for a second. What value should this get me? I'm asking for index 1 row and index 0 column. And hopefully you got that it was going to be 20, so that makes sense. Here's my index 1 row, and then that was my index 0 column. Great. Okay, so we can also do 2D array slicing. So how does that work? Let's go ahead and see that 2D array again. So there's my 2D array. Let's say I wanted a 2-2 shape array from the top right corner. So I wanted the 10-15 and the 25-30 as its own 2x2 array. So I can just do that by taking a slice. And so what I'm going to ask for is everything up to 2, and then 1 and beyond as far as the columns. So let's see if that works. And it does. Excellent. So if you look at, for instance, the columns here, I asked for the 1 column index and everything beyond it, so that would be these 2 last columns. And so that's what allowed it to take the 10-25 and the 15-30, and then to cut off the 40 and the 45, I asked for everything until the second indexed row. Okay, great. Now what else can we do? So we've been able to take some 2D array slices. We can check out the bottom row if we wanted to by saying 2 there. That would have been the bottom row. Perfect. and we can go on to something called fancy indexing. So fancy indexing, I'll show you what it means. So we can say something like, let's just make this array another 2D array. Won't put the underscore to differentiate it. And I'm going to make a zeros array. And if you remember from some previous lectures, we can say zeros. Then let's go ahead and input the size. So we'll make it a 10 by 10. Let's go ahead and see what that looks like. Okay, here's my 10 by 10 2D array of all zeros. And it looks like they're all floats. That's why there's a decimal there. And now I can get the length of the array. I can say object array length underscore length equals R2D shape of that first. And if I look at that, I should get, whoops, equal to 10. So it has a length of 10. So that's how I could get the length. So now we can set up the array. So I'm going to say for I in range length of the array. So for I in range 10 basically is what I'm saying. That array element value of I equals I. Okay, so now that we've done that operation, I'm going to check out the multidimensional array, but go ahead and think about what we just did here as far as this function. So we said for every I in the range R length, and that R length was 10, go ahead and set that element there equal to 1. So what should that do? That should give you straight ones. Alright, so that makes sense so far. What if I said equal to I? Now let's go ahead and see what happened to our array. Go ahead and think about what this should look like before you check it. Hopefully you thought about it right and you got 0, 1, 2, 3, 4, 5 all the way to 9, and then everything across is yet the same. So we only change those across the rows themselves. So every row, every value in that row equals that count number. Okay, so fancy indexing allows for us to do the following. So we can say something like ARR2D and just index it by the values in that row. So we can say 2, 4, 6, 8. Great, and so that will give us the second, the fourth, the sixth, and the eighth rows for indexing. And we can do this in any order, which is why we get the term fancy. So it doesn't have to be in order, we can just do random rows here. So I can say 6, 4, 2, and 7. And that will return the 6, 4, 2, and 7 index rows. And that's fancy indexing. So main takeaways here are, again, we've reviewed how to create arrays, and the main takeaway is how to index. So remember, this is really important. If you want to explicitly make a copy, you got to state that .copy. Otherwise, changes you make in slices of the array will affect your original array. And then for indexing, you can ask for the row, or you can get the row and the column, and you can use colons to get certain slices or chunks out of your multidimensional arrays. And that's it for indexing arrays. And we finished off with fancy indexing. Okay, next up we'll have lecture 10. I'll see you there.